concept of information systems and software. The topic of computer applications in pharmacy. Content of this topic includes introduction, information gathering, requirement and feasibility analysis, data flow diagrams, process specifications, input-output design, process lifecycle, planning and managing the project. Introduction. An information system is a computer and other technology-based method of working with information. It integrates several components, including networks, physical devices, and computer programs. An information system is a combination of software, hardware, and telecommunication networks to collect useful data, especially in an organization. An information system provides collection, storage, and retrieval of information in an organized manner. It converts raw data into meaningful information. General information system. These are not specific to any department or industry. For example, database management systems, or DBMSs, are software programs used to store and arrange vast amounts of data for subsequent analysis. Specialized information system. These systems are created exclusively to meet the needs of a specific group or organization. For instance, geographic information systems, or GIS, are used to retrieve geographic data for different regions. Further, information systems enable communication between companies and customers. Businesses may beat competitors by using information systems. Information gathering. Information gathering is the collection of data from various sources and compiling the data in desired format. These collected data is further processed, analyzed, to generate a solution of specific problem. Information gathering in pharmacy involves systematically collecting patient data, identity, symptoms, medical and medication history, and allergies, to enable safe therapeutic planning, especially for OTC and minor illness. Sources of information gathering. Information can be found through diverse sources, including books, academic journals, databases, websites, news outlets, and expert consultations. These are categorized into primary, as original accounts, secondary, as analysis and interpretation, and tertiary, like summary sources. Academic and scholarly sources. Peer-reviewed journals and academic books provide in-depth, expert-verified research. Reference materials resources. Encyclopedias, dictionaries, and annual reports are ideal for background information and quick facts. Websites and digital resources. General internet searches, company websites, and Google Scholar. Organizations and human resources. Government agencies, research organizations, experts, and consultants are valuable for specialized knowledge. News and media resources. Newspapers and popular magazines provide current events and editorial commentary. Purpose of information gathering: to enhance knowledge, understanding to a particular subject, building a complete picture of a topic by compiling data, to solve specific problems or answer research questions, understanding the environment to develop competitive strategies. Requirement and feasibility analysis. Requirement analysis. Requirement analysis is a critical phase in developing information systems. Here is the process of analyzing various requirements based on demand or problem. It involves understanding what the system must do, that is, functions, how well it must perform, that is, speed capacity, and its operational environment. Key activities: problem recognition, identify business problems and confirm requirements. Requirements collection, interaction via interviews, surveys, or observation to gather needs. Analysis and modeling, categorize into functional, non-functional requirements, use diagrams like data flow or use case models. Validation, ensure requirements are complete, consistent, feasible. Requirement analysis is important for the success or failure of a particular project. Feasibility analysis. Feasibility analysis evaluates whether a proposed information system is practical and viable before committing resources to full development. This step determines if the system can be built within constraints of technology, budget, timeline, and organization while delivering benefits. It helps decide go or no-go for projects by comparing alternatives and producing a feasibility report or project charter. Key activities: form a team and review current system deficiencies. Develop flowcharts and enumerate alternative solutions. Evaluate each against feasibility criteria using matrices. Recommend the best option or modifications. Key tasks: checks if the system aligns with business processes and gains workflow acceptance. Verifies if required technology, hardware, software, and skills. Performs cost-benefit analysis to ensure returns justify costs. Assesses if the project timeline is realistic given resources and dependencies. Key advantages: it prevents wasteful investment in unviable projects, identifies risks early, and supports informed decisions by top management. Data flow diagrams. Visualization of processing of data in systems. Data flow diagram, DFD, is the graphical representation of how data moves through an information system, showing inputs, processes, storage, and outputs without detailing control logic or timing. It is the first step to create an overview of information system. They are essential tools in systems analysis to clarify requirements and design data handling. Data flow diagrams simplify complex systems by focusing on data transformation and flow, helping analysts identify inefficiencies, redundancies, or gaps during requirement analysis. Data flow diagram symbols. For the external entity, such as sources or destinations of data, like customers, suppliers, are shown as rectangles. Data processing, actions transforming data, are shown as circles or rectangles with rounded corners. Files or databases of storage are shown as parallel lines or open-ended rectangle. Data flow shown as horizontal lines. Arrows labeled with data types. A data flow diagram is a visual tool that maps how information moves through a system or business process. Here is the representation of data flow diagram of e-learning system. Process specifications. Process specifications in an information system describe the detailed logic of how a system process works. Basically, how inputs are converted into outputs. They are commonly used with data flow diagrams to explain each process in depth. Each process specification should contain detailed requirement of functionality. Each set of process specification must specify all the rules governing transformation of data flow within an information system. Key purposes: clarifies system functionality for developers, acts as a bridge between analysis and coding, ensures accurate implementation of processes, helps in testing and validation. Key elements: process name, description, inputs, outputs, processing logic, and business rules. Input-output design. In an information system, input is the raw data that is processed to produce output. In an information system, input and output design serves as the bridge between the user and the data. Input design. The primary goal of input design is to ensure data integrity while making the entry process as easy as possible for the user. This device is important to get correct interpretation of the entered data. It is required to convert entered data into usable form. Poor input design leads to the garbage in, garbage out, GIGO effect. Key objectives. It should be simple, easy to use. Accuracy. Should minimize errors during data entry. Efficiency. It can reduce the amount of manual typing. Consistency. Use standard formats. For example, MMDDYYYY for dates. Methods of input. Manual entry. Keyboard forms. Automated input. Barcode sensors OCR. Online forms. Web-based systems. Output design. Output design deals with how processed information is displayed or delivered to users. Output is the product of the information system. It should be designed so that the right person gets the right information at the right time in a usable format. Key objectives. Relevance. Only show what the user needs to perform their task. Clarity. Use headers, clear fonts, and logical grouping. Timeliness. Ensure data is up to date. Support decision-making. Key outputs. Printed reports. Invoices, receipts. Screen display. Dashboards. Audio/visual output files. PDF, and Excel. Comparison between input and output designs. Purpose of input design is data entry. Purpose of output design is information presentation. Input design focus on accuracy and validation. Output design focus on clarity and usefulness. Input design users are data entry operators. Output design users are managers and users. Form filling is the input design. Report is the output design. Process life cycle. The process life cycle in an information system describes how business processes are identified, designed, implemented, monitored, and improved over time. This is important for understanding initial, intermediate, and final stages of growth and development in any process. Simple flow of process life cycle is identify, analyze, design, implement, monitor, improve, repeat. Main stages of the process life cycle. Process identification. The organization identifies which business process needs attention. At this stage, objectives, scope, and process boundaries are defined. Process analysis. To understand how it works. Activities, inputs and outputs, errors, or duplication in process. The goal is to find problems and improvement opportunities. Process design. A new or improved process is designed with simplifying steps, adding automation, and improving data flow. Flowcharts, process models, and system diagrams are often created here. Process implementation. The design process is put into operation within the information system. This needs user training, testing, database setup, software configuration. Process monitoring. Performance is measured based on processing time, cost, error rate, customer satisfaction, productivity. Monitoring helps determine whether the process is meeting targets. Process optimization. Continuous improvement. Based on monitoring results, the process is refined and improved. Organizations repeat the cycle to adapt to new requirements, technology changes, or business growth. Planning and managing the project. Planning and managing the project in an information system means organizing work so the project is completed on time, within budget, and according to requirements. Project planning. Project planning defines what will be done, how it will be done, who will do it, and when it will be completed. Key tasks. Define objectives. Clarify the purpose, expected results, and scope of the system. Identify requirements. Determine resources, hardware, software, and data requirements. Develop work breakdown structure, WBS. Divide the project into smaller tasks. Estimate time and cost. Prepare schedule and assign responsibilities. Risk planning. Identify possible risks such as delays, technical problems. Project management. Project management involves guiding, controlling, and monitoring the project during execution. Key tasks: team coordination. Ensure communication among analysts, developers, users, and managers. Progress monitoring. Compare actual progress with planned schedule. Quality control. Check whether outputs meet required standards. Cost control. Monitor expenses and avoid unnecessary spending. Risk management. Respond to unexpected issues and minimize their impact. Change management. Handle modifications in requirements, scope, or design. End of the topic of concept of information systems and software. Note down study questions related to this topic.